Imagine you're looking for the perfect spot to build a house. You wouldn't pick the chaotic center of a bustling metropolis, nor the middle of an isolated desert, right? You'd seek out that just right neighborhood, not too busy, not too quiet, with proper infrastructure and safety. Now, what if I told you our solar system made precisely that choice, but on a galactic scale, and that out of the 400 billion stars in the Milky Way, only a small fraction, 5 to 10%, is located in a truly safe region for life? Welcome to the revolutionary concept of the Galactic Habitable Zone, a discovery that's completely changing our understanding of where life can exist in the universe. Today, we are re-embarking on a cosmic journey to understand why our galactic address might be the most important factor for our existence. I'll reveal the deadly dangers lurking in different regions of our galaxy, show how our privileged position between the spiral arms protects us from cosmic catastrophes, and explain why this discovery is revolutionizing our search for extraterrestrial life. By the end, you'll understand why some scientists consider our location one of the greatest cosmic strokes of luck in the history of the universe. Hello, cosmic explorers. This is Cosmic Frontiers, and we're on an incredible journey toward reaching 1,000 discoverers of the universe's mysteries. When we talk about life in the universe, we always think of the habitable zone around a star, that perfect distance where water can exist in liquid form. But there's a much broader and equally crucial concept that few know about: the Galactic Habitable Zone. It was astronomer Guillermo Gonzalez, in 2001, who first proposed this revolutionary idea. He realized it is not enough to be the right distance from a star. You also need to be in the right place in the galaxy. The Milky Way isn't a uniformly hospitable place. It's like a gigantic neighborhood with its upscale areas, its dangerous industrial zones, and its quiet suburbs. Our galaxy is approximately 100,000 light-years in diameter, and we're positioned in a very specific location, about 26,000 light-years from the galactic center, in a relatively calm region between two main spiral arms. This isn't a coincidence, it's a matter of survival. Think of the Milky Way as a big city. The galactic center would be like the financial hub of a metropolis, intense, energetic, but absolutely uninhabitable for anyone seeking tranquility. There's a supermassive black hole there, 4 million times the mass of our Sun, called Sagittarius A*. Around it, stars are compressed at a density 1,000 times greater than in our region. It's like comparing Times Square on New Year's Eve to a quiet residential street. In this central region, gamma-ray bursts regularly sweep through space. The radiation is too intense to allow stable atmospheres, and the central black hole's gravity makes planetary orbits chaotic and unpredictable. Any planet attempting to maintain a stable orbit would be like trying to drive in high-speed traffic, simply impossible to stay on course. But the dangers don't stop there. Our galaxy's spiral arms, those majestic structures we see in astronomical images, are actually regions of extremely active star formation. That's where the most massive and short-lived stars in the universe are born. And when these blue giants die, they don't exit quietly. They explode as supernova, releasing more energy in a few seconds than our Sun will produce in its entire 10 billion-year lifetime. A supernova less than 50 light-years from Earth would be devastating. The radiation would destroy our ozone layer in a matter of months, exposing the entire Earth's surface to lethal levels of ultraviolet radiation. It would be like removing our planet's cosmic sunscreen. And in the spiral arms, these explosions happen much more frequently than in our quiet region. Here is a fact that might surprise you. If you could travel to one of the active star-forming regions of the Milky Way, like the Orion Nebula, you'd be surrounded by stars so bright that there would be no night. The sky would be permanently illuminated, creating an environment where temperatures would fluctuate drastically and where it would be impossible to develop biological cycles based on the day-night alternation we know on Earth. And on the galactic periphery, that's like living in the most remote countryside. Very calm, but essential resources are scarce. Stars on the periphery are poor in heavy elements, what astronomers call metals: carbon, oxygen, silicon, iron. These elements are crucial for forming rocky planets and developing complex life chemistry. It's like trying to cook a feast with only water and salt. There simply aren't enough ingredients. Our privileged location is in a region astronomers affectionately call the Goldilocks zone of the galaxy, neither too close to the chaotic center, nor too far out in the empty periphery, nor inside the violent spiral arms. We re at a perfect distance, where we have access to the heavy elements produced by previous generations of stars, but far enough from the most extreme cosmic dangers. But why do we need these heavy elements? Here's a fascinating perspective. In the first few billion years of the universe, there was only hydrogen and helium. All the other elements that make up our bodies, the carbon in our muscles, the calcium in our bones, the iron in our blood, were forged inside stars that lived and died long before our sun was born. We are literally made of stardust, but a very specific stardust that's only available in certain regions of the galaxy. The first stars in the universe, called Population 3, were giants composed only of hydrogen and helium. When they died, they scattered the first heavy elements into space. Second-generation stars, Population 2, already had a bit more chemical diversity. Our star, the Sun, is a Population I star, a veteran that benefited from billions of years of cosmic element recycling. This is one reason why life as we know it probably couldn't have emerged in the first few billion years of the universe. There weren't enough elements to form rocky planets, much less complex molecules like proteins and DNA. Life had to wait for the universe to chemically mature, and that only happened in specific regions of galaxies where multiple generations of stars could contribute their elements. Our position between the spiral arms also offers another crucial advantage: orbital stability. Imagine you're on a slowly rotating Ferris wheel. If you're in a seat that swings a lot, your experience will be chaotic and unpredictable. But if you're in a stable seat, you can enjoy the ride peacefully. Our orbit around the galaxy is like that stable seat. We have what astronomers call a circular orbit, which keeps us always at the same relative distance from the galactic center and away from the turbulent spiral arms. This stability has allowed our solar system to maintain relatively constant conditions for over 4 billion years. Meanwhile, stars with more eccentric orbits traverse different regions of the galaxy, facing extreme variations in radiation, stellar density, and magnetic fields. It's like the difference between living in a city with stable weather versus being a nomad crossing deserts and frozen tundras. Now comes the truly fascinating part. If our location is so special, it means the search for extraterrestrial life should focus on similar regions of our galaxy. We can't just look for planets in the habitable zone of any star. We need to look for planets in the habitable zone of stars that are also in the Galactic Habitable Zone. This drastically reduces the number of viable candidates. If only 5 to 10% of the Milky Way stars are in this privileged zone, and if only a small fraction of those stars have planets in the traditional habitable zone, then we're talking about a much smaller number of potentially habitable worlds than we previously imagined. But there's another side to this coin. If extraterrestrial civilizations exist, they're likely also confined to these same safe galactic regions. This means that instead of searching for life throughout the entire galaxy, we can concentrate our efforts on a much more specific cosmic neighborhood. It's like knowing that all the residents of a city are concentrated in just a few safe districts. The SETI project, which searches for signs of extraterrestrial intelligence, is already incorporating these concepts into its search strategies. Instead of randomly sweeping the sky, they are prioritizing stars that, like our Sun, are located in galactically favorable regions. It's a much more efficient approach, like looking for a specific person in a city, knowing which neighborhood they likely live in. Some scientists speculate that this concentration of potential life in specific regions of the galaxy might explain why we haven't yet detected signs of extraterrestrial civilizations. If all civilizations are squeezed into a small fraction of the galactic disk, it might be that we haven't looked in the right places yet, or that the distances between civilizations are greater than we expected, even within this privileged zone. There's also the intriguing possibility that the Galactic Habitable Zone has changed throughout the Milky Way's history. In the first few billion years, when star formation was much more active, this zone may have been smaller and located further from the center. As the galaxy aged and star formation decreased, the safe zone may have expanded. This would mean we are one of the first generations of life to benefit from the current ideal conditions. This temporal perspective adds an extra layer of rarity to our existence. Not only are we in the right place, but also at the right time in galactic history. It's like winning the lottery twice in a row. First by being born in a galaxy that developed a habitable zone, and then by being born at the right time when that zone reached its ideal conditions. When we contemplate our cosmic position through this lens, a profound sense of responsibility emerges. If intelligent life is truly as rare as these studies suggest, then every civilization that manages to emerge in the galactic habitable zones carries an invaluable worth. We are products of an extraordinary convergence of factors, not just planetary and stellar, but galactic. Our journey through the galactic habitable zone reveals three fundamental cosmic truths. First, that our location in the Milky Way is a crucial piece of life's puzzle, as important as our distance from the Sun. Second, that the search for extraterrestrial life must focus on specific and privileged regions of the galaxy. And third, that our very existence represents an extraordinary convergence of cosmic factors that occur in a small fraction of universal space and time. This understanding leads us to a deep reflection. If we are products of such extraordinary cosmic luck, living in such a special region of a galaxy, at such a particular moment in universal history, what is our responsibility as the only known intelligence in this vast immensity? Perhaps our mission is not just to survive and thrive, but also to preserve and perpetuate this improbable miracle we call cosmic consciousness. Cosmic explorers, do you believe our location in the galaxy is truly an extraordinary coincidence? Or is there some factor we don't yet understand that made our position inevitable? Leave your theories in the comments. I love reading the unique perspectives you bring to these cosmic mysteries. And what mystery of the universe do you want me to talk about in the next video? Primordial black holes, the dark energy that's accelerating the universe's expansion, or perhaps gravitational waves that are revealing cosmic events we could never detect with traditional telescopes? Leave your suggestions in the comments. We're on an incredible journey toward reaching 1,000 cosmic explorers. If this deep dive into our privileged galactic location expanded your perspective on our place in the universe, join our crew by clicking subscribe. Like this video if it sparked your wonder for life's cosmic complexity, and share it with someone else who is fascinated by the mysteries of our universe. In the next video we'll explore another phenomenon that's revolutionizing our understanding of the cosmos. Until then, keep looking up at the stars and remember, you are literally navigating through space in one of the most special regions of the Milky Way.